Welcome to week 7 of ongoing learning. This week we're going to continue solving equations using algebra, but this time we're going to have some fractions involved. Okay, so for your resources this week, you have this video that you can use, and for extra practice, use your math workbook 6.3. And for dividing fractions review, you can use your workbooks 3.6. Okay. All right, let's review from last week. Last week we went over how to solve equations when there are whole numbers using algebra. Okay, so if we have 13x plus 9 is equal to 87, our ultimate goal is to isolate for x. We want this guy over here to be by itself. Okay, and when we're isolating for variables, we're going to reverse the order of operations. So instead of doing the multiplication and division first, we're going to do addition subtraction first. To get rid of the 9, I need to do the opposite operation and take away 9 on both sides. That gives us 13x is equal to 87 minus 9. That's equal to 78. And then we're going to do the opposite of multiplication, which is division. So divide both sides by 13. And x is equal to 78 divided by 13. That gives us 6. I am not done here. I can verify my solutions to see if my answer is indeed correct. I'm going to rewrite my equation right here. And when I'm verifying, what I'm doing is I'm checking to see if my left side and my right side are equal. My left side is going to be 13 times 6 plus 9. That is 13 times 6, giving us 78 plus 9. 78 plus 9 is equal to 87. On my right side, I have 87. They're equal to each other, so that means I got this question correct. Good job. All right, now let's try when we have some fractions involved, okay? All right, x over 7 is equal to 7. X over 7 is equal to 3. Like you've seen before, when we have something over 7, what are we doing? Okay, x over 7 is the same thing as x divided by 7, right? Because fraction, when we write them in fractions, we're actually doing a division problem. Right, that means what is the opposite operation to division? It is multiplication. So we're going to actually multiply the 7 on both sides, and the 7 is going to cancel out. And x is equal to 21. Okay, to help you visualize, I'm going to rewrite this. Okay, x over 7 we said was x divided by 7. Because we're dividing it by 7, okay, we're going to multiply it by 7 to get rid of the 7. Okay, that cancels out. X is equal to 21. Okay, that's why I'm multiplying both sides by 7 to cancel out that 7. Okay, all right, to verify, we just go 21 over 7. Is that equal to 3? 21 divided by 7, yes, it is 3. 3 is equal to 3. It is verified. Okay, same thing on this one. Right now, what is happening? X divided by 5. X is getting divided by 5. So x is getting divided by 5. We're going to multiply by 5 on both sides to cancel the 5 out. And I have x on this side and 125 on the other side. To verify, I just go, okay, is 125 divided by 5 equal to 25? Yes, it is equal to 25, so it is correct. Okay. I'm going to show you why we're multiplying it by whole numbers. Okay, looking at this right here. This third question. 1 over 7 times x is equal to 3. We have 1 over 7 is equal to 3. Okay. We have 1 over 7 times x. So normally when we had 5x is equal to 10, we divided both sides by 5, right? Because we have to do the opposite operation. We're multiplying, we're multiplying 1 over 7 and x right now. So we're going to divide the 1 over 7 on both sides. Okay, see what happens when we divide. Divided by 1 over 7, divided by 1 over 7. What do we do when we're dividing by a fraction? When we divide fractions, we end up multiplying the reciprocal. What is the reciprocal of 1 over 7? It is 7. So we're actually change this to times it by 7, and this becomes times it by 7 as well. See how it's the same thing that we did in the question before? That is why we end up multiplying by 7. Okay, So if we do that, 7 times 1 over 7 is 1, so I have x is equal to 21 again. Okay? Another thing I want to show you is 1 over 7 x. When we multiply fractions, we just multiply the denominators together and the numerators together, right? So my numerators are 1 and x. My denominators are 7 and 1, because x is the same thing as x over 1, right? Because 5 is equal to 5 over 1, 2 is equal to 2 over 1, right? Multiplying by whole numbers. 7 times 1 gives me 7. See how 1 over 7x becomes x over 7, okay? Whichever format helps you solve this better, you can use either or, okay? So same thing here, we're going to divide by the reciprocal, which ends up being divided by 1 over 5, and which ends up being multiplying it by the reciprocal, which is 5, okay? So we're going to multiply both sides by 5, cancels out, x is equal to 125, same as the question above, okay? So when you look at it here, 1 over 7x is the same thing as 1 over 7 and x is the same thing as x over 7. X over 5 is the same thing as 5th x. Okay? So what is the difference between x divided by 4 and a quarter times x? It's the same thing. We are dividing x into 4 parts. It's the same thing as what's a quarter of x, right? They mean the same thing. They are the same. Okay? With that in mind, let's try some practice questions. Okay, our ultimate goal, remember, is to isolate for the variable. In this case, our variable is k. Okay, we're gonna do addition subtraction first. So we're gonna take away 3 on both sides. We have k over 7, so k divided by 7 left here, and we have -7 on this side. We're going to multiply both sides by 7 times it by 7. That cancels out, and k is equal to -49. We're going to verify our solution over here, so k over 7 plus 3, and on the right side I have -4. I have -49 over 7 plus 3. That gives us -3 plus 3, which is -4, and that is equal to -4 on the right side, so this is correct. Okay. Alright, next one we have 3x over 5 minus 10 is equal to 2. I'm going to get rid of the 10 first by adding 10 on both sides, because I need to deal with subtraction and addition first. And on the left, I have 3x over 5 is equal to 12 left. Okay, 3x over 5 is equal to 12. Okay. Now what do? Okay, right now the x here is getting multiplied by 3, but also divided by 5. So 3 times x divided by 5 is what we have. 3 times x divided by 5. So I'm going to multiply both sides by 5 first to get rid of the 5. Cancels out, and then I'm only left with 3x is equal to 12 times 5, which is 60. And then it's simple again. What do I do with the 3? I'm going to do the opposite operation and cancel out the 3. X is equal to 20. Okay, so again, when you look at this form right here, just read it one by one. It's 3 times x. It's getting divided by 5. Okay, let's verify our solution. So 3x over 5 minus 10 on the left side, 2 on the right side. 3 times 20 divided by 5 minus 10 has to equal 2. 60 divided by 5 minus 10. Minus 10, that's 12 minus 10, and that's 2. Now I have 2 on the right side as well, so it is verified and it's correct. Okay. I want you to pause the video and try the last one on your own. Okay. And when you come back, I'll solve it with you guys. Okay, so pause right here and try the last one. Alright, so let's solve this one. I'm gonna add 10 on both sides. 2 over 5x is equal to 12. Okay, so again, remember, we can divide by 2 over 5 because we see that 2 over 5 is getting multiplied to x, or we can rewrite this as 2x over 5 is equal to 12. Okay, and you see that it's 2 times x divided by 5, so I'm going to multiply by 5 on both sides. 2x is equal to 60. Okay, and then divide it by 2 on both sides. X is equal to 30. We're going to verify our solution on this side right here, 2 over 5x minus 10. 2 on the left side, I have 2 over 5 times 30 minus 10. That gives us 2/5 of 30, which is 12, minus 10 is 2, and on the right side I have 2, so it is correct. Okay, so I'm done with solving these equations. So again, the main idea is the same thing. You isolate the variable, do opposite operations on both sides, and you're going to lastly verify your solution. Okay, all right, let's do one word problem, okay, and see if we can come up with the equation to solve. All right, during the 2020-21 Highland Zoo Fest, Eric shot a total of 41, more than half the number of shots as Neelan. If Eric had 173 shots, how many did Neelan have? Okay, so I'm gonna represent shots that Neelan made as n. N is equal to number of shots by Neelan. And then Eric shot a total of 41 more than, so it's 41 more than is 41, like plus 41. More than what though? Half the number of shots is Neelan. Okay, so whatever number of shots Neelan made, and we half it, and we add 41, that's equal to number of shots that Eric made. And Eric made a total of 173 shots. That's a lot of shots, okay? All right, and then we just solve for n to get the number of shots made by Neelan. Okay, I'm just going to go over the equation again. Okay, it says Eric shot a total of 41 more than, so 41 more than half the number of shots as Neelan. Half the number of shots that Neelan made. We don't know how many Neelan made, so we're going to make that equal to n. Okay, all right, and then I'm just going to solve for n. Okay, take away 41 on both sides. N over 2 is equal to 173 minus 41 is 132. We're going to multiply both sides by 2 to cancel the 2 out, and n is equal to 264. Okay, so Neelan had made 264 shots in the game. He made 264 shots. Good job, Neelan. Alright, so when you're done this lesson, you can complete week 7, task 1.